Hi all, plan is to go through and show you how to process this data to get it ready to go into Logger Pro. Now where you are so far is you should have your trials, and this is for 10 periods of the pendulum. The one thing you don't have yet is this here, which is uncertainty and length. This here is just referring to the fact that the measurement, when you're measuring the length of the pendulum, you're not going to be able to get a perfect measurement. It's impossible to do. If you think about in terms of where you're going to actually take the measurement from on the mass and whereabouts on the bar that you've got the pendulum attached to, that measurement there is going to be pretty hard to get an exact measurement to know where the pivot point is and also know where the center of the mass is on that mass itself, especially when you take into account the string. So what we've done is we've just set that there to a reasonable uncertainty. So at the moment here, this is plus or minus a centimeter. We'll discuss that more and more in class to help you understand that more. But for the moment, just set that there to 0.01 meters. All right, so when you are processing your data, you're going to, let's go through to finish processing here. What you need to do is you're going to need to fill in these all these rows here for your particular data. So the first step here is you need to get an average. Now when you're getting an average, the average here, this is the formula up the top. The average is going to be the average of these values here. So if you're not familiar with Excel, this is what you should be using here. If you put equals average and then make sure this range here is going from C6 to E6. Do not include this over here, so if B6 is in it, that's going to bias your results down. So you just need to make sure it's taking an average of all those. Now also just another little note, for those people who are not familiar with this, if you've written equals average into here, it's got the little drop down here, you can drag that down and that there will format all the formulas across there. So you can see for this one here, now it's going for C7 to E7, so it's getting all of these ones here. Okay. Now, the uncertainty in these 10 periods, this is the first of the formulas that you're going to have to really take a look at. So what this is saying is it's looking at these ones here, and it's finding the largest value inside here, and it's minusing the smallest value, also getting the largest, minus the smallest, and it's dividing it by 2. So what it is, it's effectively the uncertainty in 10 periods there. That's just saying it's the uncertainty that we've got is half of the range of the values that you've got. That is the way that you do the calculation for that. So you can see it's got max of this range minus this, or min of this range, and we've got brackets around both sides at both ends, and then we divide the entire thing by 2. So that's what the divide 2 there is for. If you do not have these other brackets around here, what's going to happen, it's going to have the max minus the minimum divided by 2. So it's going to mess your answer up. So hopefully you should be getting something round about like that. So again, you just drag the formula down. Now, this is because we're doing our experiment with 10 periods to try and improve our accuracy. What we did is we need to now put it down to 1 period. So you can see here, look at the average of 1 period. So because it's going to be, well, in the case at the moment it's 10, what we're doing here with this formula here, it's going for F6 divided by 10. So we're just getting this down here. So this is the average period for one oscillation. And then again, same thing here with this uncertainty. We're getting the uncertainty for one of those. So you can see here, this is taking the, double clicking here, the formula. It's taking this here and it's dividing it by 10. So therefore we end up with our uncertainty here. Now, this is the next step. Normally what we'd do is we get you guys to take the square root, because it's a square root relationship. You take the square root of what is on the x-axis. But in terms of the math of this, it's a lot simpler if we end up just squaring what's on the y. So what we need to do here, as you can see, is we are just squaring our average. So you can see here, look up our formula. It's going to be h6 squared. So looking down here, this is h6 and it's squared. So this here is the average squared value for our 0.2 meter length. And then that's just a matter of dragging all the way down. And that'll give you the formulas for each of those here. So you can see this one here is now going to be the h7 squared. Now, the next thing we need to do is we need to work out we need to put our uncertainties in. Okay, So this is when we've worked out our uncertainties before. This is the plus or minus in our range. But because we're going to be graphing it as a y squared, we're going to need this. It'll make more sense when we get to actually putting it into the graph. But we need to work out what the maximum value would be, and then the minimum value would be about or plus or minus for our average. Okay, so the way we do that, just clicking on here. So you can see this is the way we do it. It's our average plus the uncertainty, and then you square it. So looking over here, it's going to be the average plus the uncertainty squared. So that there is going to tell us what the maximum squared value for our y value would be. And this is just for putting our error bars in. The next one over here, this is going to be the minimum. So it's going to be the average minus the uncertainty. Here we go, average minus the uncertainty squared. Okay? So once you've got those there, what you need to do is you need to put that down into a table. So what we need overall, actually one more thing there. Yeah, so we just need to put together a table here where we've got the length, the uncertainty in length, and then we're going to have the period squared. So that is this one up here. So it's going to be the period squared. Here we go, the period squared there. And then for our, just double checking on that there. Oh yes, then our uncertainty here. Ah yes, sorry, that's one. The last value here is going to be for our uncertainty. This is for our plus or minus for our error bars, for the length of our error bars here. We're going to need to have, it's going to be half of this range here. Okay? So that is going to be L6 minus, oh sorry, I'm trying to read, my eyes are going bad. K6 here minus R6. So that's just going to tell us the range, and then it's divided by 2. So what we need to put down into another table down the bottom, which is going to go into Logger Pro, we're going to need this, the uncertainty. We're going to need to have our average period, and that's for our y-axis values. So you can see here we've got the period squared, got the uncertainty, and then over here we're going to have the length and our uncertainty and length. These ones here have just come from above, okay? That is to copy and paste directly down. Now one thing when you're dealing with sheets, just to be aware of, if you are to just copy and paste, you want to copy and paste the values. So what you do is you go this, select your values. So go down to here. There you go, copy. Now if you're going to paste this anywhere else, if I paste this off to here, Control V, you can see here we've ended up, it's tried to paste the formulas. So what you actually want to do, if you want to place just the values, you need to press Control Shift V there, and now you can see we've got the values. So you can see what we need is we need these values here. We need the periods, you need to get from the table up above, all these ones we've been working on. You need to get these values here and then put them into Logger Pro, and I'll send you guys a video on Google Classroom showing you how to do that.